All right, hello. Well, today in this video, we're going to be looking at developing strategies for multi-digit computation with a focus on addition and subtraction. And this lecture corresponds with Chapter 11 in John van der Waals' Teaching Elementary Mathematics. So, we've talked about basic facts and working a lot with one-digit numbers. So, of course, a next step is thinking about different methods to have kids attain proficiency in working with multi-digit numbers. Like here on the left, we see some examples, and we're going to talk about that in this video today. So for a little warm-up to get started, I want you to take a second and pause the video and just work with the two math questions at the bottom of this screen. First maybe try what algorithms do you use to solve those typically, and then think what other types of reasoning or mental strategies could be used with these two. So pause the video and give it a shot just for a sec. All right. Well, there's many different algorithms that one could use here, and there's many reasoning strategies as well. For example, if we were together, I would assume that some people, for the first one, might say, well, I chose to add the hundreds first and get 700, and then I added the tens and got 60, and then added the ones and got 10. So in that way, 700 plus 60 plus 10 could be 770. And that could be one way to think about that. And the subtraction problem, sometimes someone might say, well, 89 is hard to subtract, but 100 is not so hard. So I could do 524 minus 100, and that would be 424. But that means I subtracted 11 too many, right? So I'd have to add that back on. So 424 plus 11 would be 435. So that should be 435. Those are examples of some possible reasoning strategies for those two. Well, when we look at this multi-digit computational strategies, we're going to be going through our textbook's progression of a good way to pedagogically think about developing proficiency in these areas. And just like we've talked about before, when possible, we'd like to start with things that are concrete, things that are visual, and move towards things that are more abstract. So we're going to follow that same progression here and start with direct modeling. In this case, a lot of use of base 10 blocks and strategies of counting with base 10 blocks. And from there, we want to focus on, van der Waals calls them student-invented strategies, just different mental methods or other types of different reasoning strategies to come up with the answer. And just note that in our textbook, van der Waals often says student-invented strategies, and I'll typically call these reasoning strategies, just because they might be student-invented, as students will continue to do great things with their minds, but they can also be explicitly taught and shown, and so I like to use the umbrella reasoning strategies for these. And then we'll look at, thirdly, just more efficient ways to do that with traditional algorithms. Ways that are more efficient, ways that often hide some of the sense-making, but once understood can be obviously very helpful tools to get that correct answer more efficiently. So that's our progression. So let's start here. Let's suppose we had a group of people, we're on an airplane, and there were 57 adults and 45 children. So how many total people were on that plane? Well, to start, let's go ahead and use some base 10 blocks. We're going to be doing this all virtually, and so the bottom of the screen, there's one of many great manipulative websites out there, and this one is called apps.mathlearningcenter.org. There's many choices there, and we're going to look at one called Number Pieces. So I suggest you pull that up as well on your computer. So let's take a look. So here, we're looking for how many people were on the plane. That's going to be our goal. And so we know that we're going to be looking at 57 adults and 45 children. So let's take a look. So with this type of website, on the left side we have our pieces. And so to start with the adults, I'm going to go ahead and shrink it down a little bit to make it smaller. We know we're going to have 57 adults. So there's 10, and I'm going to use the bottom here to use a duplication button. That's 20, 30, 40, 50. All right. And we can feel free to spread them around if we want. And then we need 7 more adults. So I'm going to go ahead and take that 1 and copy it. 2, 3, 4, 5, 6, 7. So there's 57 adults. And now let's bring out the kiddos. And maybe I can even color it red to make it stand out. But there's 10 kiddos. We need 45, so 10, 20, 30, 40. There's our kiddos here, and then 5 more. And by the way, if I was on a plane with 45 kids and 57 adults, that is a bad ratio on a plane. I do not think I'd want to ride on that plane myself. But 2, 3, 4, 5. All right. So when we look at it, basically here we have all of the people on the plane. And again, we can count these up one by one. We can do different things. And with base 10 blocks, we can always try and group things together. For example, well, if we put those 7 adults with 3 of the kids, well, if we want, we can go ahead and take those and trade those in. I'm using the button down here to join those together and make another 10. Still the same number of people, right? But now we have just an easier way to count. And in fact, over here, it looks like I have 10 of the 10 rods. So if we want, I could kind of grab those. And then the bottom, I'm using again, a put together piece. And it's one way of counting. And we can see if we put those people together, we would get 102 people. And so again, just using base 10 blocks, we see just a way to, again, very concretely try and put those together to see the answer there. All right. Now, so that's direct modeling. And with direct modeling, one way of organizing it as well is using things like place value mats. This one only has tens and ones, but we see that in ones place, it actually has some of our favorite 10 frames there to help us just keep pieces organized. And of course, we can have things out to the hundreds and thousands place as well. And these mats can be very helpful to keep pieces organized and just help kids structure their work a little bit. So that's an example of direct modeling with base 10 blocks. So let's take a look at some reasoning strategies here for the same problem. So 57 plus 45. All right, well, let's take a look and see what qualifies here as some different ways to think about this and make sense of 57 plus 45. So first of all, Vanderwall talks about some strategies that are partitioning strategies, or decomposing, ones that we are breaking this down. So for example, if we wanted to partition this, one way that is a great strategy is to always think about partitioning into tens and ones. Of course, 57 could be 50 and a 7, and 45 could be a 40 and a 5. And then we can put it back together, but we can group maybe tens with tens. 50 plus 40 is a little bit easier to do. That's 90. 7 plus 5, I might know that is 12. And again, putting those together, I can get that's 102. And again, I don't have to partition both of them. I could just partition one or the other, and there's other ways to partition as well, but that's just an example of a common partitioning strategy. Now, Vanderwall also talks about strategies that are compensation strategies, which I like to call sometimes rounding and adjusting. For example, if I was looking at 57 plus 45, well, 57 strikes me as one that's not particularly friendly. So maybe what I want to do is round that up 3 and get to 60, right? So let's take a look. So if I round it up to 60, well, to me, these are easier to add now. For example, I know 60 plus 40 is 100, and I add that 5, and I get 105. And I partition that 45, if you notice. The only problem is my answer should be 3 too high, because with addition, I already added 3 more. So in the end, I want to take away those 3, and I should get that same answer coming back. And that'd be an example of a compensation strategy. And we could have done it the other way as well, right? I could have rounded this up to 50, because I like 50s. 57 plus 50, well, that's 107. But then take away the 5 I compensated with, and I'm back to 102. And these strategies are just some examples here, ways of making sense of it. And our author talks about a visual approach to help students, get a strategy to think about different types of reasoning strategies. And we call it the empty number line strategy. And it's really powerful because all it is a line. It's very accessible. We get a line. And if I wanted to add, for example, 57 plus 45, there's lots of ways we could do this. What I might do, for example, is I might start at 57 and know that I need to add on 45. Now, this is where the strategies come in, because I might say, well, how could I do that? Well, maybe I'll break it up and just add the 40 first. And an empty number line, we like to use jumps, like arrows, to go through. And what I might say here is, well, I know I need to add 40, and I can do that because 40 and 50 is 90, plus the 7 more is 97. but then I know I still need to add the 5 more. So I might just do individual jumps. That's 98, 99, 100, 101, 102, and that's 5 more jumps there. And that got me all the way up to 102. And that's an example of just, an empty number line for that. But of course, it could be done lots of different ways. Just going back here and taking a look at it again, just to show, it might be, for example, just going to a friendly number. I might say, well, I got a long way to jump, so I'm going to get to a nicer number first. I'm just going to jump 3 to get to 60. And I know 100 is 40 away. I could jump 40 more. So, for example, I could jump 40 more and get to 100. And so far, I can see I've jumped 43. So I have 2 more to jump. So I'm going to jump 2 more, and that would get me to 102. I'm going to circle it, make sure I know my answer, and that would be 102. So again, these are just 2 of many examples for just thinking about empty number line. But compensation works as well. It's a really nice way to visualize it. Just going back for a second, if I was at 57, and instead of 45, I might say, well, I like adding that 50. I'm going to go jump a little too far because that I can do easier in my head. I know that's 107. But again, I know I jumped 5 too many, so I need to jump back. And taking away 5 would get me back to 102. And so the empty number line just becomes a nice visual strategy to see some of the reasoning that's possible and allow for a lot of flexibility as it goes through. All right. So that's some reasoning strategies. In our textbook, Vanderbilt has a lot of examples of that and talks about some different strategies that I encourage you to look at in the book as you're doing your assignments this week. Now, of course, we also like to have algorithms. We like to get things that are efficient and fast and take a look at it. So let's take a look at building algorithms with meaning, and that's kind of the key. I think a difference with just Common Core math and things is not that we don't like algorithms, it's just that we don't rush to get there first. Sometimes parents see students doing things like empty number lines and they worry like, why are you doing it that way? It's not very efficient. And I tell parents, don't worry, we're going to get to the algorithms. Those are important too, we're going to get there. But we first start with things that involve a little more sense making instead of rule following. So that way when we get to the algorithms, we can learn it with meaning and then have a variety of strategies. An algorithm is really just one strategy, and it's a good strategy. And let's take a look at how we can build it up and making sense with that. So on the screen here, you notice in the bottom right, there's a little bit of something I call recording template. It basically helps us to keep track of just our language and the pieces we're using to think about what's happening in a standard algorithm. So let me go ahead and pull back up our base 10 pieces here for a second. Here we have our base 10 pieces again. And you may notice here that I used the drawing tool down here with it looks like a crayon, to draw in a simple place value map, which can be a helpful way, again, to organize the work. So let's take a look at the standard algorithm. And on the right side, I'm going to use that recording template again to see 57 adults plus 45 children. And the template is nice because now we remember that when I say 57, I'm literally talking about 5 tens and 7 ones, plus 4 tens plus 5 ones, and encourages that base 10 language and thinking about place value more explicitly. So first thing we do in an algorithm is there is a right place to start. We start with the smallest pieces, which is the ones, and we know we have 12, which means we can make a trade. We know back with the base 10 blocks over here, when we did that and looked at that, we could trade in 10 of them and make a 10 rod right here. And then I can bring it over to my tens column. And that's what we see with the standard algorithm. When I add 7 and 5, I get 12. But we know we don't write 12 here because what we're going to do is trade in. We have enough to make a 10. So we put it up there to make a 10, and we know we'd only have 2 of the ones left over. And then our tens column, when we add it up, I have 6. I have 10 of the tens. But I don't write 10 here because if I have 10 of something, I can make a trade. We know back over here again, if I go ahead and select all of my 10s and do a grouping that, 10 of the 10s makes a 100. So what I do is I'm going to, again, make a trade for 1 of the 100 pieces, and I'd have none of the 10s left. And then, I know I'd have 1 of the 100 pieces left. And so again, the template in the algorithm to make sense of it, it's really all about base 10 language and just thinking about it being a little more explicit. Later on, we don't need the templates and don't need all that base 10 language, but when we're first learning, that's what gives it meaning. The algorithms are often fast because it hides all of that, but if we want to make sense of it, we just go back and put that base 10 language back in. So that is, one way to think about the standard algorithm for addition. So let's take a look at subtraction here. So here we have Walter, and Walter had 45 songs on his cell phone. Wow, that's a lot, Walter. And his little brother accidentally deleted 27 of them. Now, I'm not sure I believe it was an accident. But the question is, how many songs does Walter have left? So let's take a look at this again. So let's think about this and go back to direct modeling for a second and think about doing this with subtraction. So I'm going to go back to our base 10 blocks for the first step of direct modeling. And let's take a look. So here we go. And if I want, again, just to show I did earlier, I could draw back in those place value columns very quickly if I wanted there. One thing I want to do first, sometimes for some reason on this app though, when I take that out, often I want to shrink it down first and then do my drawing, something I've learned here a little bit. So I'm going to use the eraser tool here and just erase my drawing there. Great. And I'm going to go back and draw in my place value columns in case we want them. And the top one allows me to draw a little more freehand for hundreds, tens, and ones. Now the difference with subtraction here is to realize that if I'm doing 47, it was 47, right? 45 minus 27, that subtraction is based on taking things away with direct modeling. So I want to pull out my 45, so there's my 40 songs, and here's my 1, 2, 3, 4, 5 over there. But I don't want to put out the 27 because that's what I'm taking away, right? If I pulled out the 27 right now, it would look like I'm adding, and it wouldn't make sense because everything's already out there. I'm taking away the 27. So with direct modeling, again, there's no right or wrong order of direct modeling. I might realize, well, I know I have to take away 20, so I could take away 2 of these. Yeah, we could, and we could start with those. That's fine, and I could take away 20, so I took away 20. Now I have to take away 7, but I don't have enough ones to take away, so what I might do is, again, I'm going to bring a 10 rod here and use the break apart piece to break it apart and realize, oh, okay, so now, if I break that apart, I can bring up, for example, 2 of these, and now I have 7 right here that I could take away, all right, that Walter accidentally deleted. And what's left is I see I have 1 10, and it looks like I have 8 ones. So that would be a total of 18 songs would be remaining. And so again, direct modeling is just with subtraction to start with the initial amount and then work to do trades to remove that which is being deleted. So that is, again, one way of looking at direct modeling there. All right, so let's take a look at our reasoning strategies like before. And this is where I encourage you to pause the video and start on your own. Take 45 minus 27 and think about what are some different ways to make sense of 45 minus 27. I encourage you to use a number line as well. So take a second, pause, and work out a few on your own first. All right, so let's take a look. So with 45 minus 27, again, like before, we can do different types of partitioning or compensation strategies. So again, partitioning is always thinking of just breaking the numbers down in smaller pieces, decomposing. And let's just use that empty number line to take a look at some of these again. I'm going to zoom out just a little bit. There we go. So this time, I'm going to start with my 45 more on the right because, again, we always want the larger numbers to be on the right, just to keep that a truism about the number line at all times. And so partitioning, I might say, well, it's easier just to take away the 20 first. So sure, let's do that. So I would jump left this time, but I would take away 20. So that's 35, 25. And I still need to take away 7 more. I could even break that 7 up into 5, so I know I could take away 5, and that would get me to 20. And I still have, let's see, 2 more to take away, and that would get me down to 18. And I always like to circle the answer there on the bottom. So again, just it's very flexible. There's lots of ways we could have broken up and partitioned it, but here we see going back to 18. And some things about this. I want to encourage you to always use the arrows to show what direction you're jumping, to label your jumps, to circle your answer. It's just good practice to help label the work to make it a little more friendly for students to think about, encourage them some good habits as well. But of course, we could also use a compensation strategy, which might look something like this. Well, 27 is not very friendly to take away, but it's really close to 30. So what if I just took away 30? What if I jump back to 30? If I did that, see, I could count back by tens, 35, 25, that would get back to 15. But I know I took away 3 too many, so I'm going to have to compensate. I'm going to have to jump back 3 the other way and get me back to 18. And that would be an example of a compensation strategy. Now, there is another thought with subtraction as well, which also works, which I'd like to show. And it is that another way that we'll see students and us do this sometimes is actually starting with 45 and 27 on the number line and realizing that subtraction is just the difference between these two numbers. So if I started with 45 and took away 27, one way of thinking about it is there's a difference between these two. And certain wording for story problems would be more meaningful for this. For example, I could say Adam had 27 songs, Aaron had 45. How many more did Aaron have? Kind of a comparison problem. And this would work really well for that. But just to show that even if it's a problem like that, we can also solve a subtraction problem by figuring out the difference between these two, which might look like this. I might say, well, I want to get to a friendlier number, so I could jump up 3 to 30. And I know I could jump 10, and that would get me to 40. And I know I have to jump 45 more to get me to 45. Great. Now, when I do it this way, it's interesting because the answer is not down below like it was up here. Now, it's the difference between those two numbers. So it would be the total number of jumps I did up here. And adding those together, I would see that that was a total of 18 jumps. So that's also another valid way to use an empty number line for subtraction. And those are some sample reasoning strategies. So great, so let's compare that with, again, the standard algorithm and take a look at making sense of the standard algorithm again. And like before, when we do that, it's all about base 10 language and thinking about what's happening with those pieces. So I'm going to go ahead and start over with pulling out our 45 songs again. So 10, 20, 30, 40, 50. And let's pull out the 5 up here. 1, 2, 3, 4, 5. All right, so there's 45. And let me pull up my recording template as well. And I'm going to see if I can get so we can see everything at once again. So let me pull back this one here and put this back up in the corner. Perfect. All right, so let's write down what our question is. We have 45 minus 27. And again, we see it in the place value columns of tens and ones here. Now, unlike direct modeling, there is a right way to start the algorithm. I need to start in the ones place. But if I'm trying to take away 7 songs from 5 songs, we know I don't have enough, so I need to do a trade. And so over here, what I might do is, again, realize, well, I can trade in one of these groups of 10, and I'm going to bring it over to the ones column and hit my ungroup button. And yeah, now I can move that around and take a look. And now I easily have enough songs, and so I can take away those 7 right there, right? And here's what I have left. I have 1, 2, 3, 4, 5, 6, 7, 8. And that's what happens in the standard algorithm. I can't take away 7 ones from 5 ones, so I make a trade. So I come over here and cross off the 4 because I'm going to borrow. I'm going to take one. I'm going to make a trade, so I only have 3 left. And when I made a trade, I got 10 more ones. So over here, there's different ways to do this, but sometimes I just put a 1 in front because that's going to always be adding 10. So I traded in a 10 here, and I got 10 more ones here, giving me a total of 15. And when I took away 7 of them, I had 8 left. And that just shows that trading process, again, of trading in a 10 for 10 ones, and that's what we do when we cross off and put the 3 and move a 1 over there. And then the last thing to do is to take away 2 of the 10s. Did I start with one too many pieces here? It looks like I may have goofed a little bit. Sorry about that. I'm going to move that over there. I should only have 3 left over there. I think back to what I did wrong there. Sorry about that. But I have, so 3 10s minus 2 of the 10s. So I take away these 2 10s and delete that. And I have 1 10 left with 8 ones for a total of 18. And that would be, again, one way of thinking about the standard algorithm of subtraction and some language to think around the place value columns with what happens when we're doing those trading in there. All right, great. Yeah. And again, in our textbook, Vanderbilt has some nice strategies too in thinking about that. One thing he said was subtraction, that, again, he likes to use place value mats that have the 10 frames on that. He also said for some students that need the extra support to remember you're taking away 27, sometimes he likes to use little cards that just remind us that that's what we're taking away. And so it helps us remember what we're trying to do is take away 2 of the 10s and 7 of the 1s. So a nice little strategy there. So I have a challenge for you. I want you to pause the video for a second. I want you to try this. We're going to try some larger numbers and try this question. If the zoo had 603 snakes in the reptile house and 89 of them were sent to a wildlife institute, how many were left at the zoo? So I want you to take a second and try it for a second. The base 10 blocks link is at the bottom there. So see if you can start with 603 and do what you need to do to take away the 89. Then think about some reasoning strategies with that empty number line or others. And then using a recording chart, try and see if you can just use base 10 language and practice talking out loud what that would sound like to use base 10 language to talk through the standard algorithm. So go ahead and pause the video and then we'll see how you did. All right, well, I'm going to use the direct modeling with the algorithm in just a second. So let's just compare what you might have done with some of the reasoning strategies. So again, there is an empty number line we'll start with. So let me draw that out right here. And we know 603 would be on the far right of the number line. And we know we want to get rid of 89 of those snakes. So this is one where a compensation problem might work really well. For example, 89's kind of a not friendly number, but what if I decide to take away 100 instead? If I take away 100 snakes, that would give me back to 503. But I know I only needed to take away 89, so that was 11 too many. So I need to jump back 11, which would get me to 514. And that would be, again, a compensation strategy, kind of rounding and adjusting. But again, we could have used partitioning as well for sure. And to take away 89, it might look like this. I'd rather get to a nice number, so maybe I can take away 3, and that would get me to 600. And then I could take away 80. I'm taking away a lot of snakes here. I could jump back 80, which, again, counting back by 10s, I realize gets me to 520. And that's 83 jumps so far. But I still need to take away 6 more, and that would get me to 514. And that would be, again, a partitioning strategy and a compensation strategy going through. And again, just to show it, if, just the other way as well, if you happen to think, well, you kind of liked just to see the difference between 603 and 89, we could, and that could look like, adding 11 to get to 100, jumping up 500 to get all the way to 600, and jumping that last 3. And again, in this method, all together, that would be a total jump of 514 as we see it. So let's take a look at that direct modeling and see how you did with that. So let me pull up the base 10 pieces again back here, and I'm going to go ahead and just clear out the pieces from before. All right, get rid of all those and get rid of that extra 10 I had earlier. And let's put in the 600 snakes. So here are 100 snakes and 200, 300, 400, 500, 600. And I'm going to put in the 3 over here. And like before, as we said, the key here is not to put in the 89. You don't want to do that with direct modeling because that's our goal, is to remove that 89 as we go forward. So here is the question again. I'm going to write it right here. We have 603 snakes. We're going to subtract 89. Now, again, using base 10 language, we always start in the ones place, and I can't take away 9 snakes from 3 snakes, so I need to do a trade. As we see, though, but I don't have any 10s to trade in, so the only thing we're going to have to do is trade in 100. So let's take a look at what that looks like. So over here, if I take a 100 and trade it in, well, we know that that means that I would have 10 of the 10s, right? Going through over here. And that's what happens over here. In the standard algorithm, when I need to go to the hundreds place, well, I'm going to trade one in. So now I only have 5 left. And again, when I put a 1 in front here, it's a way of just showing that as we trade in groups of 10, that means I would have 10 of the 10s, right? I traded in a 100 piece for 10 10s, and that's what this shows here. Now, I have something I can trade in to get some 1s. So let's do that. Over here, I could take one of those 10s and bring it over and break it up. And yes, now I have enough to, take away, to do what I need to do to take away the 9 that I want to take away. So let's take a look at that. So there's but let's take a look at that. Before I take it away, let's go back over here and see what that looks like. Again, when I trade, I'm going to cross it out and put a 9 because I traded in one of my 10s. And when I put a 1 here, it's because I got 10 more, right? Now I have 13 total, and that's what I see with my base 10 blocks. And now I can take away those 9 because I have plenty of snakes to do that over here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to grab these 9 right here and get rid of those. And yeah, so I'd have 4 of the 1s left over. And in my 10s place, do I have enough 10s to take away the 80 snakes right here, those 8 10s? Yeah, I have 9 10s, so that's plenty. There's 1, 10, 20, 30, 40, 50, 60, 70, 80. There's 8 10s right there. And I can get rid of those. And that would leave me with 1 of the 10s. And I see I still have 5 of the 100s left. So in the end, I have 500 blocks, 1 9 rod, and 4 1s for a total of 514. And again, we just see how with thinking about the base 10 language and the blocks, all of a sudden all this trading and things up here, it makes more sense. And if you notice, I chose to use the word trading and not borrowing, just for the reason that borrowing tends to think you're going to give it back, right? And we're not really giving it back at any time. We're just trading and making a trade. So that's my choice of language there. All right, well, let's wrap this up. So as a recap, we just have seen again that we've really talked about 3 important phases here of direct modeling, of thinking about, in this case, we use a lot of base 10 blocks, but to really do something physical, to see it, to see how the answer makes sense. And we're not focused on the exact right way to have to do it, as long as we kind of make sense of the pieces. And then we talked about our reasoning strategies. Again, sense making, flexible strategies, focus on number sense. And lastly, we get to the efficient methods of traditional algorithms. But it's not just about teaching how to do it, but still want to make sure it makes sense. Using that base 10 language, using, the recording charts help us think about that, what's actually happening. And the goal is to understand it so we can explain it and use it. All right, and that is kind of our recap of the first part of chapter 11. So, all right, so until next time, all right, I'll see you later.